Dear participant, thank you for joining the yacht session. We should start actually. Okay, okay. Yeah, thank you so much for joining the yacht session. And today we will discuss what is the role and what's the impact of the yacht in the AI and energy nexus. Actually, we should want to go to just want to like to discuss some points, potential ways to just want to answer what would the AI say about that. Actually, this session organized in partnership with the IEEE, IEEE Young Professionals, and Kooti Agrivoltaics. I am the moderator of this session, and I am the chair of the IEEE Young Professional Digital Transformation and Innovation Hub Subcommittee. And we have also one distinguished speaker and yacht speaker, actually, Georgios Paliouras. He is the head of the R&D at Kooti Agrivoltaics. And before starting our fireside chat side, actually, I want to just introduce the IEEE. Maybe you couldn't hear before, actually. Yeah. And IEEE is the Institute of the Electrical and Electronic Engineer. It is recognized as the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE Young Professional Program engaged nearly 100,000 young professionals across the world, working in professionals closely with the related to energy transition. What is the main impact of the YP? Yeah, kind of young professionals and young professionals who have graduated with their first professional degree within the past 15 years. If you have graduate within the past 15 years, you can join the IEEE Young Professional team, actually. You can just see here, that's our innovation ecosystem. We have some engagements with governance agencies and academia and industry. You can just see here, we have also kind of partnership with the United Nations, Student Energy, Student SDG Yacht, and IRENA, actually. We just want to just build the capacity building and the know-how structure for our young professionals environment. You can just see here, we have the sections, including New York, Tunis, Jordan, Lebanon, Egypt, Turkey, United Emirates, and we also have regions located in Africa, Europe, South Asia, Pacific, South Asia, and South America. In IEEE, we have local groups we just want to call the regions, actually. Right now, you can just see one of the example here. New York is allocated in Region 1, and Chicago Region 4, Lebanon Region 8, yeah, Jordan as well, Region 8. We officially communicate this kind of the section, regions, and official local groups through our communication channels. We are almost have around at least 100,000 young professionals around the global level. Previously we participated in IRENA Innovation Week. You can just see here. We are almost here today, and just want to we want to just continue this partnership and engagement level side, actually. We also participate in IRENA Yacht Forum at Abu Dhabi, and we just want to discuss how to empower the young professional in the energy translation platform, actually. And we also organized one of the AI training session. Just want to discuss where to start and how you can just use the AI in your platform. We just want to build that kind of capacity building environment. We also just organized this event in Abu Dhabi, actually. Yeah. You can just see it here. That's our engagements with the IRENA side, actually. I want to just also mention that one of our ongoing initiative right now, we are just preparing the guidebook on the artificial intelligence and energy transition side, actually. We just want to create the policy-oriented guidebook, including not only technical perspective, actually. We have 4 different chapters. First one is the interaction level, and just want to mention that the taxonomy, where to start and how we can just want to continue. And then we also just want to provide in the section 2, just want to discuss the technical perspective, how we can model energy transition side, and also just want to provide the use case studies around the global level. And in chapter 3, we just also discussed the market level and the business transition, business landscape, how we can just go to your startup innovation ecosystem. In section 4, we also discussed some challenges like the eco-diverse inclusion criteria. These are our AI and energy guidebook project. We have a yacht leads. You can just see here, Hamid and Cecilia and me. We are leading this project. We have the diversity author list from the global level, and we just want to share our the experience, how we should want to just reflect that's the current landscape from the global level. We have also another ongoing initiatives like kind of the challenge, and yeah, we just want to organize challenge events. Just want to the initiative how you can go to your idea into the innovation ecosystem. We will discuss later through our fireside chat. I want to just start our session, and I want to invite to our distinguished speaker, Georgios Paliouras.
Hello, Polat.
Yeah, hello.
Hello, everyone.
Yeah, we should start please introduce yourself. Then. Yeah.
Thank you very much for the opportunity. I'm very happy to be here today. As Polat very kindly introduced me, my name is George. I'm 24 years old, and I'm a PhD student at the University of Florida. The last 2 years, I'm leading the research and development in our startup named Kooti Agrivoltaics, where we are trying to mainstream agrivoltaics, the integration of the generation of renewable energy with agriculture. To achieve this, we have implemented different AI models and different AI approaches over the last 2 years. So Polat, feel free to start the conversation. I'm happy to answer any question and share my experience over these years, over this area.
Sure. Thank you so much for a kind introduction. Actually, we should start the first part, actually, the AI and Energy Nexus interactions level. And the main point is that for the young professional practitioner side, actually, where to start, actually, and how we can just want to define the metric, or just want to define your idea or problems. We can just start the first question: what exactly is the AI and renewable energy nexus? It means that, in simple terms, how would you describe the AI and energy nexus to someone new into the field, actually?
You can think the AI renewable energy nexus as a two-way interaction. On one hand, we have we are using AI to make renewable energy more intelligent, the entire energy ecosystem more intelligent through applications like forecasting, wind and solar photovoltaic output, operating microgrids, or even detecting equipment failure even before it happens, days before it happens. So AI can help us digitalize the energy ecosystem. And on the other hand, we have the energy that we use to train AI. AI is using huge data centers and state-of-the-art data centers. They might consume as much electricity as one small city. So yeah, think about it as a two-way interaction between the artificial intelligence and the entire energy ecosystem. And if we think a bit out of the box and we make the category a bit wider, the Nexus integrates from mining resources for the batteries we use in renewable energy, or even the manufacturing of photovoltaics. So yeah, it's a very, there are a lot of value chains in this Nexus and a lot of steps. So it's multi-layer and very, very complex.
Yeah, that's a great point. Actually, we should want to just use the AI kind of to making more efficient and predictive and adapt to some kind of the complex variables. You mentioned that the kind of grid demands and storage and kind of weather and the climate change. I want to also just ask what are some of the ways AI is actually being used in the renewable energy side, actually? And it means that what are the current key applications or like the scenarios of AI in renewable energy that young practitioners should be aware of? Because the thing is that they need to know that how they can just want to like to go to check some kind of the resources or some materials and just want to like to be aware of the where to start actually.
I think, and what we use in Kooti Agrivoltaics is forecasting for the output of our photovoltaic panels. And this is also well established in wind output. We have also predictive maintenance. There are applications that we integrate AI models that gets as an input the vibration frequency of the gearbox of wind turbines. And by this way, we can detect any fault or failure like some weeks or days before it even happens, and we can be proactive and go and fix the damage. We have grid operations, and I think here in Germany there's a startup called Next Fahrwerken or something like this. I may misspell the name. So what they have done, and I think that's very impressive, they have created a virtual power plant, and they are able to coordinate like thousands of roof photovoltaic systems and wind turbines and biogas units, and they can in real time like balance between supply and demand, and that's very impressive.
Yeah.
Let me tell you something else that I consider very, very interesting. It's also around photovoltaics area, and it's kind of similar with biological applications. Like they have created AI models that can predict the 3D structure of proteins and enzymes by getting us an input like the amino acid. We can have something similar in the research for photovoltaics material, because only 1% of the photovoltaic materials that potentially can replace the well-established silicon technology, only 1% of these materials have been actually made in a laboratory. So we can use AI to try and model and predict if a potential new material can be actually working, and then we can manufacturing. And I think that will be very promising, like application of AI in renewable energy, at least for the next years.
Yeah, that's a great story, actually. I want to ask you that question here. How did you just choose use AI, and also like kind of what is your like the initial point? How we can just want to start like the process actually? Maybe you can also explain that kind of your experience, how we can implement the AI. Why you just want to just choose the artificial intelligence strategy, or for example, not just apply for the data analytic platform actually, kind of.
Yeah, so from my experience, because my background is mostly agricultural, and I'm working with AI the last 2 years, I think the most important is learn about the frameworks, learn about the models, but go even deeper, learn about the mathematics, focus on linear algebra, focus on calculus, especially if you're not coming from a background like electrical engineering. I think it's possible not to become the top expert, but you will be able to understand and apply. So if you want to go deeper and you want to engage in AI, especially in the renewable energy, I think you need to decide in which step of the value chain you want to focus on, because the options you have are endless. You need to spot like a process that needs improvement, and this can be like from biofuels to photovoltaics to agrivoltaics or to any process of the value chain. So after you find the problem and you have clear stated your value proposition, you need to decide if you are gonna go to academia and research, or if you want to commercialize the product. If you choose academia, you need to find a master, PhD, or like working in a research center. If you go for commercialization, you can participate like in hackathons, like what we hear yesterday, like IRENA hackathon, or start like in accelerator programs and incubation programs, and step by step start to build a team and trying to create the final prototype.
Yeah, that's a great point. You mentioned that we should think about like the architecture, and it means that how we can just design the data architecture platform to just wanna start your artificial intelligence application process. Actually, it is not the way to just use only just artificial intelligence tools. We should wanna just like to create the how we can design our problems and how we can go to the structure. We should wanna call like data architecture platforms. Yeah, we should also talk about like what are the opportunities and pathways for the yacht practitioners they can just follow up. And I want to just ask you a question from your perspective. Where do you see the biggest entry points for a yacht in AI and renewable energy side?
I think more or less the entry points can be through academia or like commercialization steps through your own startup. What I think is like very promising technology in the renewable energy AI Nexus, and maybe it's like worth it to engage with, is autonomous energy agents. So I think Tesla did something similar the last months with their battery system. Imagine a network that all the appliances like EVs, smart appliances, batteries, roof solar is interconnected, and they are able to decide when to charge, discharge, or sell the electricity back to the grid. Don't only based on the price, but on the weather forecast, even on the local grid needs, or even your calendar. So I think the next step of especially the grid operations, they will be more decentralized. These systems will be able to dynamically communicate with each other and dynamically respond. So the top-down model we have now, and it's kind of has its own problems. With this kind of like autonomous energy agents, I think they can optimize this problem, and AI can help and automate this process. Also, another entry point may be digital twins. These digital twins are able to mimic like the actual physical system as a simulation. And these digital twins can be used as actual, like imagine as a flight simulator, but for energy networks. So the grid operator can run different scenarios like extreme weather conditions or specific failures, and they can act appropriately.
Yeah, I would like to also add some points, and which want to just focus on either domain or knowledge-based expertise. It means that entries should be like include the data analytic roles or like kind of the system startup solutions. Yeah, you also mentioned that to either solutions like kind of academic base or like the innovation perspective. Yeah, kind of AI-driven climate and modeling or like open source innovation should be a critical problem actually. Like later, we want to just address how we can just address the open source. We are using like kind of the open source tools, but how we can address the open source innovation frameworks actually. That's also another emerging technologies we can just work later. Yeah, and the next question, what skill sets should young professionals prioritize if they want to work in AI for Energy Nexus? And which kind of the skill sets you want to just like comment actually, they can just start working on that area?
I think the most basic skill set is to know a programming language, ideally Python, which is very, very easy to learn and program with. You can use frameworks like scikit-learn for basic ML, or if you want like neural networks and more advanced applications, I think very important to know TensorFlow or even PyTorch. Now, depending on which area you want to engage with, you can find open source libraries online. Like, for example, we are using photovoltaic prediction models. We are using PVLib from like National Renewable Energy Laboratory. I'm pretty sure that depending on each sector, corresponding models that are available online. So, and as I mentioned before, spend some time understanding the background, understanding the mathematics. It's not, you will become much more efficient if you understand what you are doing than like applying just a pipeline, because, and this is more for people like me that they didn't have like the academic background on AI. There are a lot of courses online and tutorials on how to implement these models, but if you don't know actually what's happening behind, you won't be able to do a lot of things in this sector, especially if you target to pure innovation and you want to make something that can really work and commercialize in mass scale.
Yeah, that's another critical point, actually. Yeah, that's a technical perspective. We should also consider how we can just like to work on the policy-oriented, for example. Right now, we are just working on the AI and RE Guidebook project, and just want to try to highlight how we can also think about just create your idea and just want to form the structure, go through the process. Like the data architecture is a critical part. We need to fit into the data and also how we can just align with the regulatory aspect, and also just want to learn how to communicate with the policy-oriented. That's another should be like the skill set. Young practitioners should be work that area. We should also discuss like some point of the technical or like the modeling challenges, and because we also have some kind of the limitations or barriers how we can address actually. I would like to ask one of the question here. What are some of the top modeling challenges within the AI in this space? And you want to just like highlight, or for example, that you can just mention from your experience.
I think especially for AI grid operations, energy grids are very complex, high dynamic, non-linear systems. Physical constraints like Kirchhoff's laws, like voltage limits, thermal inertia, all of these apply. So it's difficult for standard machine learning that is usually trained in clean, stable data. It's hard for these models to detect like very critical and rare data in the system, like transformers failures or cyber attacks. So one main problem with the existing datasets is that this kind of dataset we want AI to predict are very rare. So the datasets we have will be highly, highly unbalanced. But even the datasets are a bit hard to get. Like most of the grid operators, they used supervisory control and data acquisition systems that are considered legacy. They are a bit outdated, and they don't have a common protocol to work with. So they may have, like, for example, different time resolutions, or they are mostly unlabeled, and that's also a problem. We need labeled data to work with. And some private companies also, in some countries, like, for example, in Florida, the company that, there are 4 companies that are running the grid, so each company has its own operation system, and these data are proprietary. They are not easily and public accessible. So I think we need more collaborative data sets on this, and more we need a standard for this data so we can work all together.
Yeah.
Let me add something else also about the scale. Like when we try to optimize a model for a microgrid, like for a house, AI, it's very easy to be trained. But when we have a huge grid, like with thousands of solar PVs and EVs and houses and basic power plants, the scale, it's huge, and we don't have like the room for any mistake. This is a critical infrastructure, so the scale also is a consideration for this.
Yeah, you mentioned that like the handling the nonlinear data structure and also just the real-time optimization across the distributed energy networks should be a critical problem. And also just want to highlight that the main items, how we can explain the outcomes of the AI tools actually. It means that we should want to just call trustworthy or like the explainable models, because we should want to just provide some kind of the outputs to just want to explain, for example, if you want to just work with diverse countries or just want to cultures, you should want to just adapt that kind of the points how we can just go to the process, which want to call the regulatory aspect, but we just want to like to design the trustworthy or like the trustworthy taxonomy actually. Right now we just want to call human-centered AI approach actually. That's another landscape how we can address that kind of challenges. Yeah, I would like to ask another question for the technical and modeling challenges part. Are there particular challenges in data quality, availability, or interpretability actually that young innovators should be consider actually that perspective? How they can just want to go through the process to just address actually?
Especially for grid operation, I think the events we want to predict are very rare, so that's one problem, as I already mentioned, and also these data are unlabeled, but also depends on the sector of the data we want to use. For example, the quality data for weather forecasting is very, very accurate. Data about biofuels production are also publicly available, and they are also accurate. So I think it depends on the sector. The quality of data you can use in this kind of applications depends on which sector you are trying to implement a solution.
Yeah, I want to just mention that here, and just one of the method actually here, we are using the co-design framework. Just want to like the incorporating the diverse stakeholders, just including finding the common ground language. Just want to talk, for example, that's a main challenge to find the data spectrum actually, and how we can just want to like create a high resolution spectrum or like the time spectrum range. That's a way to just want to work with a co-design framework with the diverse stakeholders. It should be a potential solution to just want to create the co-production framework to design your potential AI solution. That's your own benchmark actually to address that kind of challenges. Yeah, another question is that here, can AI models work anywhere? Like kind of, do they need to be customized actually? It means that how can AI models be adapted for different geographical or like the cultural context actually?
I think that's necessary. For example, in Kooti Agrivoltaics, for each region, we need to customize and localize our models. I think it's the same in the grid operations. For example, if you have a model trained in Spain, you cannot go and apply it in a community, in a microgrid community in Kenya. We have the climate is different, the cloud pattern is different, even the infrastructure behavior is different. The same goes for the grid infrastructure. So there are ways that we can localize these models, either through retrain them or use transfer learning techniques, but I think localization is necessary.
We should also discuss the ethical and equity considerations, because that's also a critical part, how we can just align with the regulatory expect, and how do we enable that the AI-driven solutions for renewable energy are equitable, like accessible and sustainable, especially for underrepresented communities actually.
That's true, and that's a question we can't ignore. So I think what we should do is, from the beginning, we need to be inclusive. We don't need just to innovate in big cities and make these models work in big cities, but we need to include data from off-grid communities or micro-community grids. And I think it's very important to engage these communities in this process, because we cannot have easily data from them. So if we engage with them, they can help us make these models from them. And the other thing I would say is these models need to be transparent. For example, if we want, like in a case we need to apply grid shading, like cut off a specific region, like out of the network for any reason, and AI is make a decision, we need to make sure that this area that is cut off the grid, even like temporarily, why this area has been chosen. Is it a biased decision? Maybe is some like poor area of the city or poor community is like being like is the first option for the AI instead of like a research community, or like which infrastructure we prioritize. So I think the grid operations and the providers of this kind of AI needs to be transparent and need to be accountable for this.
Yeah, it is critical to engage with the local stakeholders to just want to like understand that kind of.
And let me add something about sustainability, because AI is using a lot of energy to train AI and to implement AI and to run AI. If I remember correctly, this by 2035, like 2% of the worldwide electricity will be going to data centers just for this. But what we expect is like in the perspective that the energy that we use to train AI, which is huge, is just a fraction of the energy that AI can help us save. So in total, like the total balance is like a positive balance.
Yeah, for the sustainability aspect, we have like direct and indirect cost, actually how to train and how to just design the hyper optimization process actually. Right now we prefer like the lightweight AI solutions, how to address the like, if you want to just work the big data set platform actually, that's the one of the potential solutions, just want to prefer the lightweight AI solutions actually. Yeah, and we should also discuss the future aspect and what is our vision actually, how we can go to the process for the yacht practitioners actually. What is the most exciting thing on the horizon of AI in renewable energy sector actually in the next decade, and what do you want to just like to see for the next decade actually?
Could I say agrivoltaics, which is my sector, and I think we are very, very benefit from AI, and I think without AI this couldn't be able like to build the system we have built now. But I think, as I mentioned before, autonomous energy agent is the future into decentralization of the grid, and also the digital twins is very promising. But this is also depends on which step of the value chain we are talking about. There are very interesting projects going on in biofuels right now, and how we can use AI into the genomics of different microorganisms that can that can photosynthesize like in an artificial environment. So that's another example. So in my opinion, AI has like endless entry point, and there's a lot of research that should be done and can be integrated in a lot of steps of the energy AI nexus.
Yeah, we should like that's a big starting point actually for the AI applications, or how we can just go to the process to design your AI solutions. Actually, I want to just like mention a couple of items for the future vision. And one of the items is the human-centered AI approach. We can just design how we can just incorporate the human like the expertise controlling side actually of the model. And the other one is the vulnerable AI solutions, or we just also discussed some kind of sustainable AI perspective solutions, like kind of the more resilient and decentralized and user response grid systems should be we should want to work later. Later, it means that the near future, like the next month or maybe next day, we should want to adapt how we can just go to the process to understand the AI process. We should call like the data architecture, how we can design our process. It means that we need to learn to start where to start and how to continue, how to just want to create our own, we should want to just call the benchmark. It means that how we can create your own solutions actually on that step for the AI applications.
And sorry to interrupt you, Polat. I think very important that we need high quality data sets. We need an adequate amount of data, because even the best AI in the world, if it hasn't got good data, it won't predict correctly. If you have a random data set, you will have random predictions.
Yeah, that's a way to just want to create the high resolution data set. But if you couldn't reach that kind of the big data set platform, we can also create the synthetic data set platform. But the thing is that here, how we can just control, how we can just want to manipulate it means that how we can explain that kind of your outcome. That's a critical point actually. And finally, just want to ask, why is collaboration in the AI and energy nexus is so important? It means that what role or which kind of role do you see for the interdisciplinary collaboration in building the AI energy solutions as a kind of high impact solutions actually?
I think exactly because the nature of this implementation, this nexus, is like very complicated. And for example, AI engineers, they don't understand how the grid operates. Power grid engineers, they don't understand AI. And on the other hand, we have the regulators. They need to apply some limits. They need to be able to ensure that these tools reach sustainable goals and promote equity. So on the other hand, we have the communities. We need to be able that the communities will accept these solutions. So that's why I think teams like that have coders, modelers, community leaders, regulators. So all of these needs to work together. So the final products not to be just like technologically brilliant, but to be actually useful and like future-proof.
Yeah, collaboration is a key milestone. How to just want to create the exact, or what you want to just like to get an impactful AI solutions. Actually, collaboration bridges like the technical, policy, and social perspective. For example, within the IEEE, actually, we want to just create like a transdisciplinary approach. How we want to work together. Actually, we don't want to just work on the project-oriented base. Actually, we just want to understand what you can just talk each other and just want to create that meaningful outcomes. Actually, yeah, that's I guess from our question list, and we can just want to continue our set of questions. And if you have any kind of questions, we can also we are more than happy to answer your questions actually as well. We have one question here.
Yeah.
How can you strike the balance between the energy efficiency and the use of AI, knowing that the AI is energy intensive? It means that how we can just want to like the balance. Yeah, we just discussed that point actually.
Yeah, I don't
the cost effect side.
I don't think we can balance it, but what we expect is at the end, AI can help us save much more energy that we require for training it. So
actually, just want to highlight here, we should want to just get a balance between the use of AI and the energy efficiency. The thing is that we should want to create the awareness, how we can just want to go to the process to understand how to use AI. That's one of the particle, and how to just want to implement that your process, how to go to create your own solutions. These are like some kind of the stages how we can go to the process. But the thing is that you should understand what is the meaning that, and what is the background of the AI, how it works actually. If you just learn that kind of the language, it means that we should want to just balance the energy efficiency and the use of AI. And for example, you should want to just optimize your hyper-optimization process. It's a kind of the way to just want to control or to balance the energy efficiency and the use of AI. The second question is that how do you see the role of the IEEE in bridging AI innovation and the renewable energy implementation? Actually, right now we are just working on the first item is that here we just want to like to create the awareness and also just want to like to create the capacity building and the knowledge sharing side, because that's a critical. We just share the like we can just reach the different geographical positions, and also not the only technical person. We have also policy and social science related scientists and research scholars. We have. Actually, we just want to like create that the capacity building platforms. Actually, we just want to like to understand how we can implement the renewable energy solutions. For example, one of the items here, we just want to prepare the AI energy guidebook, and the other one is right now we are working on the AI energy certificate program. Actually, that's another way to just want to like to create the innovative idea, because we have like the freedom. You want to just like to provide the creativity solutions and just want to like to create your own pathway. We have like the partnership within the IEEE and also external bodies like, and one of our engagement is ARENA actually, and just want to create that kind of know-how and capacity building to create the impactful and to learn from your side actually, and then we can implement that kind of one of the item is the renewable energy side actually. The third one, yeah. How do you think Agrivoltaics can integrate AI-driven resource monitoring? Are you working with any data partners or AI systems?
That's a very good question. So basically, in Kooti Agrivoltaics, what we do is we monitor like different environmental parameters. We have the weather forecasting and the predictive forecasting for the PV output. And at the same time, we use computer vision in AI on the plant material, on the plant canopy. So we are able to get the photochemical reflectance index that show us what is the current state of not quenching photosynthesis. So we are able to identify the stress of the photosynthetic apparatus. And this way we can optimize our panels can change angular positions, or we can in real time optimize this process about how much light we need to give to the plants, and at the same time, how much energy, how much electricity these systems needs produced per day. Because to mainstream agrivoltaics, they need to be financially feasible. So we have daily electricity thresholds, and we try to optimize the shadow effect with the energy output per day at the end of the day.
Yeah, thank you so much, Georgios. We should want to just conclude our session, and thank you so much for sharing your inspirable the experience and know-how. That's almost grateful for us, and I hope our young practitioners, they can get their knowledge actually where to start and how they can continue that pathway like you actually. Thank you so much for joining.
Thank you very much.
That session. Thank you. Also just want to join that yacht session. Yeah. Yeah, sure. Let's get a picture. Maybe we can just get all here and just get a picture as well.
Okay.